Wait a couple minutes. Hopefully some more people join up. All right, so what we're going to do today is we're going to go over the Sun worksheet that I gave you guys earlier this week. There's only 10 questions. We're going to get through this pretty quick, and then you guys can enjoy your weekend. I am going to sign another packet over the weekend that we will go over most likely on Wednesday, okay? And next week, we're going to be going into other galaxies and what makes up space. So for the Sun worksheet, the first question they give you is they give you this giant graph that we have to read. And on one side, it says the number of sunspots. And then it gives you the activity scale on the other side. Now, this is important when we're reading it because if you actually notice, there's two different lines. So they give you basically one line going like this, and then we have a lighter line that basically goes with it. When one line goes up, the lower line also goes up, and when it goes down, it also goes down. And then at the bottom, it basically starts at 1840, and it goes all the way up to just off the scale at 1930, okay? So basically what they're asking you is the graph indicates that years having the greatest number of sunspots occurs. So we have to look carefully, and you notice that the bottom one is your sunspot. And then the higher line on the graph is the activity of magnetite, okay? So basically what this is showing is we have to figure out where there's the amount of sunspots, and then when does it go up again. So if you look at a couple of them, you'll find that the average range of years between the higher number of sunspots is about 11 years, okay? And it's a predictable pattern, okay? Because we kind of know that it's going to keep happening every 11 years. Now, for number 2, according to the graph, what approximate year did the most sunspots occur? So this is really important because we have to make sure that we're looking at the bottom line of this graph, okay, or this chart. So basically, we have to just find the year, and then if we follow it down, it comes out to being 1860, okay? Now, for number 3, what they ask now is the amount of activity and then the number of sunspots. So for this is really important. So basically we're just looking at this chart and we're noticing that as the activity of magnetite goes up, so does the sunspots. So what we have to do is we have our 4 different graphs they give us, and it shows that it doesn't stay the same. It doesn't decrease when activity increases. It doesn't decrease, and then it doesn't just go straight up as it shows in letter D. So the only choice that makes sense is A, which shows that as the amount of activity goes up, so does the amount of sunspots. So those are for the first 3 on the front page. Now for number 4, and I'll erase all of this, because now these questions are going to be using basically the notes from the PowerPoint and then also our Earth Science reference table. So for number 4, it's asking us which of the forces listed below is most responsible for the formation of the sun. And the one that makes the most sense is gravity, because when we talked about it, how the Big Bang happens and you had all those dust particles and matter in space, over time, the gravity was able to bring it in and now it's that giant ball of fire that we see today. Number 5, which process produces the largest amount of energy given off by the sun? Now, it's nuclear fusion, and it's making into lighter elements, okay? Because you got those large elements that are reacting inside of the sun, and it's giving off the smaller elements that's giving us our sunlight here on Earth. Energy is produced within a core of the star by the process of. So when we're talking about star, sun is one of those stars. We're going to talk about the other stars in the universe next week, but basically the key factor that's happening inside of our star, which is the sun for us, it's nuclear fusion, okay? All right, so for number 7, what is the sun's period of rotation at its equator? So when we're talking about the equator, remember, we're always talking about the middle and how far it's actually rotating around. So the sun also rotates, okay? And then we rotate and we revolve around that sun. So for this, we actually have to use our reference table, okay? So you're going to go to the back page, which is page 15, and you're going to notice that we also, even though we have the planets on that back page, we also have the sun at the top. Now, some of the things that are left blank is the mean distance from the sun, because we're not going to be, that is the sun. Period of revolution, it's not moving around anything. And then the eccentricity of its orbit. Remember, every planet has a different orbit, but since the sun is the center of our solar system, it's not moving around anything. So what we have to do is we have to find the period of rotation of the equator, which is the 4th one box over. And if we look at that, it's going to give us that the sun is actually rotating at the equator at 27 days. Now for number 8, what does the approximate mass of the sun make up in the solar system? So this one comes right from the notes. So it's asking you, at everything in the solar system, how much percent-wise is the sun compared to everything else? So we're talking about all the different planets, all right, our gas giants, and all the asteroids, the comets, the meteors, Earth, all the moons. What percent is the sun compared to everything else? And the sun is still 99%, okay? That's how big the sun is in our solar system. It's still 99% of all the mass in it. So for number 9, it says if Earth's mass is 1, how many more times massive is the sun? Now for this is in the notes, but also if you don't have the notes in front of you, and remember for a test, you're always going to have that Earth science reference table. You can again go to page 15 and you look at the mass, and it gives you that Earth equals 1. And you'll see that for all the other planets, it gives you how many mass. So for an example, Jupiter, which is very large, it is actually 317.83 more times the mass than the Earth. But for this, we're looking at the sun. And for that, it gives us 333,000 more times, okay? And again, I just look right at the reference table, and I find it right on this chart. So for number 9, it's going to be 333,000. And then for the last one, it's asking you what's one of the elements that combine in the sun that allow it to produce energy. So this kind of goes to the notes, and then also just because we're talking about the sun, we know that it's made up of hydrogen. So the choice is going to be hydrogen. Okay, so these are the answers for that sun worksheet. If anyone had any problems for it, again, I know you guys have a couple more worksheets that we're working on. Just try to get them in, and then I'm going to be grading them over the weekend. And I am going to be posting another couple of questions for the weekend, all right? And then we're going to go over it on Wednesday. On Monday, we're going to go over the solar system questions, and it's going to be the same time at 1 o'clock, and I will post it for anyone that can't make it at 1 on the Google Classroom. If you have any questions, please let me know, and I will see you guys later.